Good morning and greetings to all the attendees joining this webinar series on MeshWorks. It's always a great pleasure to have you all. And in this webinar, we are going to focus on a very important aspect of MeshWorks. It is focused on CAE process automation. And for this session, I am joined in by colleagues Abdul and Gautaman. And we would like to walk you through the following agenda, as you can see on the screen. As first part, we are going to introduce you to MeshWorks. For all those who are attending for the first time this series, this will be very informative for you. Subsequent to that, we are going to talk about the process automation methodology that we follow in MeshWorks. It's quite different from all the other automation processes that we are used to. It's a very quick, elegant four-step process of walking through the steps, recording the steps, plumbing all the relevant panels, and then deploy them. And even though we prepare for an application, we can always use the process automation tool across workstations, across disciplines. A process automation built for a certain operation in automotive can also be used in aerospace. So it's quite flexible. We are going to see how we are going to build that methodology, and then we are going to see some of the application of process automation in automotive domain, heavy engineering domain, and the aerospace domain, where we are trying to showcase the key difference the automation brings in, saving a lot of time that we spend manually today. So that's one of the important aspects. And lastly, we are also going to talk about the process automation application for biomedical. Here we are going to showcase how from a rudimentary CAD data, we are able to walk and create a high quality mesh data, how process automation enables that. So we are going to focus on those aspects during this process automation webinar session. To talk about MeshWorks, it's the CAE platform from Detroit Engineered Products. Our idea is to support the CAE activities that happen in automotive, aerospace and defense, heavy engineering, biomedical, shipping and energy verticals. At the present time, you can see MeshWorks playing role in the area of model building, model integration, setting up the simulation models for optimization, post-processing the CAE results. So these are the several aspects that MeshWorks plays a critical role for these domains. MeshWorks as a software was a leader in the area of numerical model or CAE model, CFD model morphing, and subsequently preparing the models with parameterization for optimization. So then, as part of version 8, several other important modules have been added up, which includes the CAD handling modules, mesh creation modules, then model assembly modules and post-processing modules. And process automation module, as also you can see here, is very key and it's an important pillar of MeshWorks. So with all these modules, it's a CAE platform that is ready to go and help CAE users. This pie chart clearly identifies what are all the key pieces of the puzzle from the MeshWorks side. So MeshWorks clearly addresses your pre and post-processing needs. That is from the perspective model building for the solver, as well as post-processing the results from the solvers. So as I mentioned earlier, MeshWorks is a leader in morphing as well as parametric CAE model technology. So those continue to be our leadership areas, and with the help of the parametric CAE modeling technology, you also see us playing a greater role in enabling design optimization. Even non-parametric based design optimization is also enabled very well by MeshWorks toolsets. Today, our presentation and demonstration is going to focus on the process automation pie, which is also very important, and the way we do the process automation is also different, and we want to demonstrate to you live how do we create process automation. As I already mentioned, MeshWorks is a CAE platform And here it's very well clear with an automotive context. We've been able to showcase that it is able to cater to building models uh, of various complexities and make them solver ready with all the connections and contacts. And this can happen for all the world-class solvers that many of the CAE community uses today, the LS Tyna, Astron Simulia, and for the CFD application, Star CCM. So it caters to all of those top-class solvers. The key differentiators of MeshWorks, as we also wanted to take your attention to, are essentially the four pillars. That is, the parametric model is one of the key pillars, where the model that you create is automatically parametric. Integrated modeler is another important pillar. There is process automation that is associated with that as well, which will be demonstrated to you today, which is that you start with a single CAD database and end up with multiple FE models. Then there is an automated modeler, which is, I can also call it as the process automation module, which is the subject matter of the webinar today. And lastly, there is an associative modeler, which we will take it up in another webinar and let you know how the existing mesh model can be automatically updated to the new CAD that is coming into the system. So these are the four important differentiators that MeshWorks has compared to the other tools that we are aware of. In this webinar, as I mentioned in the contents section, we are going to focus on the process automation methodology, and subsequent to that, we are going to see demonstration of the process automation for the various industry verticals and how do the CAE users from these verticals can save time using MeshWorks. So the process automation methodology point of view, it's a very simple way to create process automation. It doesn't expect the CAE user to be master in any of the programming languages. It's a very simple, easy to use, and all it needs is we have to walk the process once, record it. MeshWorks has all the recording options to record the steps that the user uses, and after that we can see the entire process deployed on the canvas. We can establish the necessary input-output connections, which we call it as plumbing, and then we can save this and we are ready to go. So it is as simple as that. That's what my colleagues are going to walk you through. Then we are also going to address one of the important area as part of our automotive process automation, which is to be able to demonstrate to you the breadth of MeshWorks to be able to handle various type of connections as we try to convert model from one discipline to another discipline. How does MeshWorks understand and convert the different ways the spot welds are modeled, different ways the adhesives and body glues are modeled between crash and NVH, the different ways the clips that connect the body exterior plastics to the body structure. How do we handle all those things? Different ways of how the seam weld gets modeled between crash and NVH. How are we able to take care of all those conversions? This is expected to save a lot of time for the CAE user, and we want to demonstrate you our process automation for that. There is yet another process automation that we want to bring to your attention. This is for the heavy engineering users who typically handle very thick sheet metal parts or cast parts, and the welding as a connection process is involved. And here the weld happens to be either a tetra weld or a hexahedral weld with heat affected zone. And there is an automation that is built in MeshWorks, and that saves you dramatically a lot of time. And this is something that my team would like to bring to your attention today. Subsequent to that, we will also see how the process automation can even be taken to the next level. Today, the process automation is talked about as a set of steps which will walk you from the CAD data as input and will give you results as an output. So that is how the process automation is orchestrated. But what we typically add from the MeshWorks side, yet another dimension and complete the process, is we are able to even automate the creation of these beads or creation of lightning holes. For example, in an aerospace wing rib, if we take that as a context, you can see how the process automation can play out. After you have the results, we can identify areas which are quite blue in terms of its participation to the performance, and in those areas we can see if we can create candidate lightning holes. or if there is an area where we need to improve the lateral and longitudinal stiffness, we could end up creating beads. So this also can become part of the process automation, leading you to solution. So that's something that my colleagues are going to demonstrate to you today. And lastly, my colleagues are going to demonstrate to you today how we can start off with sometimes a rudimentary line data as input and arrive at a high quality solid mesh for as critical application as a cardiovascular device. So to that extent, we want to showcase the process automation tools and the benefits to the CAE users today. So I would hand over the stage to my colleague Abdul and Gautaman, who are waiting to demonstrate to you live how to create process automation and how all these applications are giving very quick results to the CAE users. Over to Abdul. Thank you.
Yeah. Thanks for the nice introduction, Karthik. So here the user wanted to create a bead. It's why because like he wanted to increase the lateral stiffness here. So he wanted to create a bead, and which is a repetitive process he is getting, and the user wanted to create it as his own process automation very quickly to recreate the beads again and again. So for the initial step, like as we discussed earlier, like the very first step is our recording process. So I will go with the recording now. So here something called as record designer MSF button. So here the user will click on and he will save the main file. So I will create a folder for it. So I will name it as a recording file, and as you can see here, it's a green button now. So it's because like it started recording. So once it started recording, the user can perform. So whatever the process is going to execute on this particular process. So the same thing I will also execute. So initially the user go for this. So we are going for the basic mesh, and we are going to do the feature insert and cut. I'm going with the methodology of smooth insert. So I'm giving the input of the cutting shells. So let's assume this is our outer 1D elements. So I will just select the outer 1D elements and I will select the base component. So here I have mentioned partitioning the cells so that the elements will partition and give you the output. So the next step is like the user will select. So let's assume this is the inner 1D element. So we will select that 1D and the user will specify the output as cells, but now the user can specify with process sets. So which is nothing but the output of the older process, like the whatever the process we executed before. So it will get some outputs to you. So that output you can select it for the next input without selecting in the particular panel. So in the process sets, I will just select that. So here we can see, so whatever the input the user have specified and whatever the output we got it. So this is the smooth insert result 2D elements. So this 2D element I will select it for the insert and I will say cut. So now we have the separated components here. So next step I am going to create a offset here in our own morphing panel. So in the offset I will go for the freeform morphing. So the same way like all the outputs we can specify it here directly by selecting the process. For the control nodes I will select the inner 2D elements. So which is the second smooth insert 2D. So next for the deformable I will select these entire 2D elements. So for the fixed nodes I will just constrain with the edge of this particular bead. Same with the process. So I have selected this 1D as the fixed nodes and I will say accept and create a freeform offset. So once after creating the freeform offset, I will just link it. So the offset I will select it to this, whatever we created now, and I will say accept and link it. So once after linking, the user will go to this translate function, tools, translate. So for the control nodes also the user can specify. So here I am not selecting anything in the window. So directly the user can specify in this particular panel itself. Accept. And in any specific direction. So now I am giving for the Z direction and say translate. So it's now marked perfectly and accept and return. So this is the process the user going to execute for each and every bit every single time. So this is now recorded, and once after recording I will just stop this recording and I will show the recording how it is now. I will open this in a text pad. So here you can see, so it's not kind of a scripting or anything, like whatever the panel you are executed in the or pre-processing, so that will be entered as a command here. So which is the first smooth insert, second smooth insert, and created a offset, then I linked it and I translated it. So this it's a very simple process, and also like whatever the inputs we have fed it in, so either we need to partition or anything, so we can specify it here directly. I'll just close it out. So, once after executing the first step, so then next step we will go for this creation of GUI panel. So in the file, so we will be having something called as go-to designer. So in the go-to designer, the user going to create a panel as well as the process for the whatever the execution process for the PA. So here something called as Toolbox. Here the user can give the buttons of anything whatever he wanted. So I will just give some 3 buttons for the 3 inputs whatever I am selected there, and the same like execute, reset and return button, which is the default one for all the process automation functions. And one more input is the direction. So whatever the direction I am giving for, like I can give. So once after giving, like he can edit this buttons, like I am just naming the each and every button. So in the properties, the user will specify, so what is the name of this button. Currently I am specifying as outer 1D elements, so which is the first input. So next is the base shell, so I will name it as base 2D elements. So the third one is like I will name it as inner 1D elements. So this is for the naming purpose. So once after creating, giving the buttons here, so the button has to talk with the process. So we need to give some properties to the buttons. So the properties will be panel will be containing, so whatever the process the user going to select with this particular button. He is going to select a single entity or the multiple entity. So he will give this, specify this here. With the filters we can specify he is going to select the nodes or elements. Next, the tab sequence, which is nothing but like, so which is the first button, second button and the third button for the execution. So the same way we are giving these properties for all the other buttons also. So in this particular case, like for all the 3 buttons, it's the same selection only, like all elements only with the multiple selection. So I'm giving this button as tab sequence 3. So for this one, like it is just a text control box. So whatever the value we are entering here, so that will be fed in as a variable. So this doesn't have a tab sequence. So at last we will be giving as a execute, which is the tab sequence 4, and we will save this panel. So in this particular panel, I am saving it as bead panel. So once after creating the panel, we'll give the process here in this execute button. So I am typing as bead process. So in this bead process panel, so you can see like we can have a tab called bead process. Here you can call your own recording directly. So as you can see here, it's kind of a flow chart. So whatever the process you have followed in the pre-processing, so that will be given as a flow chart to you. So this is the very first feature insert, which is a smooth insert. So here in your left side you can see, so whatever the inputs the user is going to give, and this is the output of the particular process, whatever the user is getting as output. So for this input, so we can specify the buttons here. Like you can clearly see, select the group cutting elements, which is our 1D elements, so outer 1D elements. So I will just drag and dropping it, that's it. I'm not doing any process. Like for the base elements, like this is a cutting shell, so I'm giving just directly dragging and dropping it to here. So this will be having some of the outputs, which is like 1D group and 2D group and resultant group, which is the combination of two groups. So here you can see, like so though I have selected the process sets, the resultant 2D is already in a loop, like the blue line which is connected to it. So this is for the second process. For the second process, the group of cutting shell is the output of the first process. So for the 1D elements, the internal 1D alone I will give as an input. Just drag and drop again. So next for the morph set. So as you can see, like though we selected through process sets, so it automatically connected each other. Like the 2D group of the second output is our control node, and the deformer node is the first 2D group, and the fixed node is the first 1D group. So it is very clear, like the user can clearly identify so which is connected to what. So I'll just hide all those things. So next, after the offset creation, like we will be linking and unlinking it. So even though we, if at all in this particular process we delete something else, like let's say this link I'm deleting it, so we no need to worry about, because like in the functions panel here in the left side, so we can have all the tools, properties, basic mesh, all those panels here. Whatever the pre-processing panel we have, so we will be having here also. So from here in the morpher panel we have the link and unlink offset, which we can directly choose in, and we can like just link the offset here by just dragging and dropping it, and now I'm unlinking it after the process. So as you can see here, there is no connection between these nodes which are like each process. So this one can be easily connected to this connect button. So directly just clicking to one process, we can just connect it. So which all have designed very easily and efficiently for the user. So now for the translate alone, like the user will specify, so which is your direction. So for the direction, I am just calling this particular text control box. So the control nodes only is getting translated. So once after saving this process, we can just exit it, and we can directly execute it in the panel. Like I'll just open the text pad and show you how the process looks now. So this is the process now. So before unlink was not there, and now the unlink was here. So whatever the process we are adding in, so that will be directly edited to the text pad. So we no need to worry about so coming and changing here or anything like that. So like if at all any empty descriptions are there, anything is there, if you want, no one wanted to be there in the process, so we can directly delete it in the text pad itself. So now I will directly open the process here. So here something called as open designer panel next to the go to designer. So I will open this panel. So the user now will select what are the inputs he have given in. So the outer 1D, the base 2D, the inner 1D, and he will specify the directions value, and he will say execute. So now the same process, whatever I followed here, has been executed here also with very few inputs. Instead of going to smooth insert multiple times and creating the offset and translate. So now if at all the user gets with only two 1D profiles, he can quickly generate the beats very soon. So this is very easy and clear process which is very transparent. So the next process I will just execute it, so which is a very quickly created process automation and which is very efficient. So as you can see in this panel, it is a wing box of an aircraft which is an for the structural stiffness. So they have created like this, so here we have something like in the cross section, internal cross sections, we wanted to reduce some weight. So we created some lightning holes parameter. So I will open up that panel. So this seems to be very small panel, but it contains lot of process in it. So here now the user going to select only two nodes, and he will select the base component. Next, the user will specify the axis, so which he wants the width of the punch hole or the lightning hole, and he will specify some width for particular lightning holes. Let's say 25. So this is based on the user's input, and he will say execute. So this have lot of functions in it, which is the same way whatever we have seen in the beat, like it has some n number of functions, so which is like 20 number of functions in it, and we have so created a whole like a slot here with the width of 25, as you can see here. So this is like a very quick way of reducing the weight in aerospace modeling. So for the next process, I will go with the biomedical. So for the biomedical, so we will be getting a stent modeling, the input as a CAD curves. So with the CAD curves, so we can generate the CAD surfaces very easily. So from CAD surfaces, we used to generate the mesh very quick way of, we have a lot of very quick way of generating the boundary oriented mesh. So this is the output of the boundary oriented mesh. So from the 2D, we have one more process automation, which is like planar to cylindrical option. So this process automation is nothing but, so whatever the flat surface is there, so we can just roll it to cylindrical surface. So now the user is going to give only the elements as input, and he is going to specify the axis. So in which axis it has to revolve. Then the user is going to specify, so what is the radius of it, and the thickness he will specify, and the layers. So how many layers along the thickness. It's going to create the solids also in it. So the user is going to say execute. So basically what it does is it directly revolves the 2D mesh, and it is going to create the 3D mesh also in it, and then the 3D mesh, it automatically splits into 4 layers along the thickness of 1. So as you can see here, so this is the thickness of 0.1. So these are micron mm mesh, so which is very tough to handle in other tools so it is very easy to handle it here. As you can see, it's rolled perfectly and equivalent and create layers also around it. So this is a very quick way of generating this. So this is also a PA functions. So from here I will hand it the stage to Gautaman. So he will be showing you some of the cool features to you.
Thanks, Abdul. So so Abdul has shown some cool automations with some simple models. So I would like to also show some complicated automations. So in the case of a model conversion, what you're seeing on the screen is a cut section of a VAW model, so which has all the spot welds, seam welds, RV3s, rigids, etc. And in this case, we have created a very cool automation wherein the user can identify all these kinds of connections, and in one push of a button, he can convert them. So I'll just directly go into the vehicle conversion module here. So in this case, user can just select on identify spot welds, and the tool automatically identifies all the spot welds in the model so that the user can review them and then deselect some of the regions if it is not required. And the next one is he'll go to the identify adhesives. So the adhesives are identified, and then let's go to the identify seam welds, and the seam welds in the model gets identified. And it also highlights in the canvas. So this is a very customized process. So our process automation can handle all the kinds of customization, starting from a very simple process to even a very complicated process. So let me switch on all the components so that you can see all the rigids, which is nothing but the seam welds has been identified. And then let's move on to the next one, which is the identify rigid patches. So it identifies all the rigid patches in the tools, and then move on to the next one of identify the CNRB elements. So once all the elements has been identified, so we can just click on the button called as convert crash to NVH. So this will enable a text pad starting that the process has been started and etc. And in a moment, I'll just open the output model itself, as it is going to take a couple of minutes to do the conversion. So I've already exported the output model. So this is the output model of this automation tool. So as you can see, all the spot welds has been converted, the seam welds, and the automation is capable of handling intelligently even the rigids, which is having single connections as well as a bolt connection kind of a rigid. So in the case where here you can see that only the rigids are being created, whereas in a case like this, you can see a rigid and a rigid is connected, and with tolerance, it is automatically creating a link element. So that is one. And the second one is, after running the automation, there should not be any kind of dependency issues. So as you can see, in all these kind of areas, it is creating a rigid with one layer of washer. In certain areas, it is not creating, because when it is trying to create in such a way, we might end up with some dependency issues. So the automation can also handle these kinds of checks and balances, so that just out of the tool, the model can be a runnable tool. So this is one example of a vehicle conversion model. And the next example I would like to take is a kind of a tetra model, wherein we would like to create weldments for tetra elements. So the usual process in order to create a kind of weldment is to create a CAD data, or if an existing weld data is available, the user can use the data, trim the lines, and then do all the regular meshing process to bring up the node-to-node connectivity. But in the case of this particular tool, none of that is required. So no dependencies. User can mesh this bracket component separately, the axle component separately, and then come to the automation tool. So I'm just going into the seam welds, and here I just need to specify where my welds has to come. So in this case, I'll just specify a node by path, wherein I'm going to enter both the extremities, and then I have to select my master component and a slave component, and the type is going to be weldment. And here we have three types, whether we just want to merge the nodes, or after merging the nodes we also would like to create a contact, or without merging nodes we just would like to create the contacts. So let me go with coincides nodes with contacts, and then we have the inputs for the solid weldment. So in this also we have a lot of options. That is, either we want to have a flat profile, a concave, a convex profile, and then I can specify the caudal height as well. And either we have to start with the convex and end with the concave in order to exactly replicate an actual seam weld that is happening in the component. So, and then I just give preview weldment. So in this case, taking the solid weldment as an input, the preview is created. So in this case, there is no kind of nodal connectivity, and here you can see it is kind of a convex profile weld with all the inputs that has been given in the solid weldment. And the moment we say realize, the tool starts creating the node-to-node connections between the base component. And the beauty here is, we understand that in the kind of tetra components, people start nowadays creating layered tetra mesh. So even though the axle component is going to have some 3 or 4 layers, and the bracket is going to have some 3 or 4 layers, we are only going to disturb the top layer. So the layered tetra mesh is also not disturbed. So as you can see now, there is a nice node-to-node connectivity between the weldment and the brackets and the axle components. And since we have given a contact, so it is also creating a contact. So these are all very quick automations and little bit complicated automations that we have created. This would be another example for heavy engineering.
Yeah, from here you can take the stage, Karthik.
Thank you very much, Gautam. And if you could make me the presenter, then we could present our concluding remarks.
Sure.
So thank you very much for all the demonstration, Abdul and Gautam. And I think the way we presented the process automation procedure, that was very good. And I would like to bring to the attention of the CAE users is that the key value proposition from MeshWorks is always help CAE users achieve the drastic time reduction possible in the CAE workflow. Many a times it is the mesh modeling automation which will help you reduce time. Many a times it is the connection mechanisms or the process or the steps that you do. Automation in that would help you save time. And sometimes it is while you convert a master model in one particular format created for one particular solver into another format for another solver. In those conversion process, the complexity in terms of translating all the connections in one particular format into another, that's a great deal of manual effort, and that is where the process automation is expected to save time. So that's what my colleagues have taken the chance to demonstrate to you as to how easier it is to create process automation. We did not write several lines of code or anything. We just carried out the process once, recorded it. That's the key piece of the puzzle. And then we were able to plumb the process with all the inputs and outputs, and we were able to deploy the process. And you saw all that happening right in front of you. So we are committed to ensure that the CAE processes that as a standard operating procedure that most of us use, it's very easier to create automations for those using MeshWorks, and you can look at significant time savings using MeshWorks process automation methodology. And as you saw, the process automation file that got created is very simple to use, and it could be moved from one workstation to the other workstation. And also there are already several process automation created in MeshWorks. They're ready to use and available. They can be accessed from the top right corner of your MeshWorks window, and they're available as workflows which are already process automated, and it is available. So we are very committed to help the CAE users in the area of process automation, and we feel it is a great step forward. Also, our demonstration has covered one more important aspect, which is not just the time saving part, but also another part of creating solutions. if we, based on our results, if we find there are certain areas where we should stiffen, certain other areas we should create lightning holes, be it a sheet metal part, be it a cast part. So we will be able to create those countermeasures also and then continue towards the solution. So the process automation need not have to be a standard process of starting from CAD and leading to result, but it can start from the CAD and go towards the solution also, and MeshWorks is your key tool set in this area. So this is what we want to bring it up to your review today. We hope this was quite informative to you. We look forward to have you in the next webinar, and if you had missed any of our earlier webinars, you could also go to our website and you could see the earlier webinars where we have explained some of the key attributes of MeshWorks, and I would request you to stay tuned to hear back from our marketing team on what next topic we are going to address and bring to you all on the time saving and how we are transforming the CAE side of the business as far as the engineering activity is concerned, and it is across the discipline, right from automotive to energy, aerospace and defense, biomedical and heavy engineering. Thank you so much for your time. We really appreciate it. Thank you.